Imagine a star that can spin 43,000 times per minute. Of course, I'm talking about pulsars, rapidly spinning neutron stars that are a stellar remnant of what was once a star 4 to 8 times the mass of our sun. See, when stars that are between 4 and 8 solar masses no longer are able to fuse lighter elements, they begin to collapse because the energy that once was pushing out against the immense gravity that was pushing inward is no longer there, and the balance is gone. As the star collapses, protons and electrons are forced together, and that's when you get this. What is left is a stellar remnant that is about 95% neutrons, a material so dense that if the algorithm sent you here, you've no doubt heard the example that 1 teaspoon of the material weighs about, I don't know, 10,000 billion elephants or something like that. We're not here to talk about the weight of neutron stars. We're here to talk about how fast they spin, and the battery on my camera is about to go out, so let's get this done. Some neutron stars emit radio waves in the form of beams at their magnetic poles, and when these beams are aligned with our line of sight just enough, we hear this sound. This is a pulse, and this is where they get their name, pulsars. And they pulse at regular intervals, so much so that when they were first discovered, it was thought that they might actually be extraterrestrial life, but instead it was far, far weirder. See, what they found was a remnant of a star that was spinning incredibly fast. How fast, you might ask? You've no doubt heard the example of a spinning ice skater who pulls their arms in, and due to the conservation of angular momentum, they spin faster. So take that principle and put that with something more massive than our sun. It's spinning, and then that mass gets compressed down into something that's no more than 20 kilometers in diameter. It is going to spin very, very, very fast. In the case of the Vela pulsar, it rotates 11 times per second. According to NASA, the Vela pulsar emits jets of charged particles that, as they so lightly put it, race across the rotation axis at 70% the speed of light. That's around 210,000 kilometers per second, but they've discovered faster. The second fastest that they've ever found, and I'm gonna have to look at my script for this, is PSR J08520607. It moves at a breakneck speed of 42,000 rotations per minute, and it reaches that speed in a very interesting way. It actually has a companion star that it's stealing mass from. So as it's gained more mass, its rotation speed has increased. But this is only the second fastest known. Currently the fastest known, this one that I'm not even going to try and say right now, rotates 716 times per second. That's just under 43,000 rotations per minute. But get this, that's only 60% of the theoretical limit of how fast pulsars can spin. It's theorized that they could actually spin up to 72,000 times per minute. Anything faster than that, astrophysicists believe the object would break apart. The universe is an amazing place, and if you like hearing about this stuff, well, guess what? It's your lucky day, because I like talking about this stuff. So if you're so inclined, give me a like, a follow, a subscribe, comment, do the things for the algorithm, and I'll see you next time. Bye.